I'm tired. You're tired, Alexis. Got my time back. A lipid is a carbon-containing compound found in organisms that are largely nonpolar and hydrophobic. Lipids do not dissolve ever in liquids consisting of nonpolar organic compound. No. Lipids do dissolve in liquids consisting nonpolar organic compounds. Got 20 minutes of notes here. Okay. Fatty acids are the key building blocks of lipids. And lipids contain a hydrocarbon chain bonded to a carboxyl group, and that's COOH. Fatty acids differ in the number of C length and the number of double bonds. Trans fats are rarely found in natural growing food and other sheep than small animals and cannibal. Hydrogenation of vegetables leads to the formation of trans fats. Trans fats are found in like solid oils like shortening, margarine, salad dressing, crackers, snack food, baked goods, fast food, and convenience foods. 3 types of lipids are found in cells. The 3 most important types of lipids from the cells are fats, steroids, and phospholipids. A saturated fat is a straight line ellipsis, and unsaturated are kinked, and they're kinked because they have a CC bond, a double bond. And a fat looks like a glycerol linked by ester linkages. So it looks like an octopus, really. Um, the structure determines the function. Melting points of fats depend on the structure of constituent fats and number of double bonds. Functions of fat: help the body absorb vitamins, serve as energy reserve, cushion and protect and heat other vital organs, protect bones, and provide insulation. Steroids have a bulky four-ring structure. They have a polar hydrophilic head and a nonpolar hydrophobic tail. And then phospholipids are amphibolic molecules. That means they have two parts. On the top, they have a polar charged or charged group. Then they have phosphate and a glycerol. And then they're linked together by a fatty acid. Two fatty acid tails. I don't think you'll have to draw that, but we'll see. Amphibolic lipids spontaneously form micelles and lipid bilayers. Hydrophilic heads interact with water, and hydrophobic tails interact with one another. Yeah, so soap is a micelle. And then, phosphobiolipid layers have selective permeability. High permeability is O2, CO2, and N2 because they are small nonpolar molecules. Then the next second easiest one to get there is H2O and glycerol. They're small and charged polar molecules. And then the third one, not really easy to get there, is glucose and sucrose. And they're large uncharged polar molecules, and ions don't go through at all. It's an unfavorable towards to them. Lipid bilayer with short and unsaturated hydrocarbon tails have easy permeability and fluidity, and lipid bilayers with long saturated hydrocarbon tails have hard or strong permeability. Or low. Low if it's long and saturated, and high if it's short and unsaturated. Adding cholesterol to membrane decreases their permeability to glycerol. The permeability of all membranes analyzed in an experiment increased with increasing temperature. The fluidity of the membrane. Phospholipids are in constant lateral motion but rarely flip to the other side of the bilayer. How quickly molecules move within and across the membrane is a function of temperature, the structure of the hydrocarbon tails, and the number of cholesterol molecules in the bilayer. Factors that affect membrane permeability. That would be the chain length, cholesterol, and temperature. Cholesterol mood lowers permeability. Sorry, repeat after that. Diffusion. Osmosis is a type of diffusion. The movement of water is called osmosis. Osmosis occurs only when solutions are separated by a membrane that permits water to cross but holds back some or all the solutes. Diffusion, all dissolved molecules and ions or solutes have thermal energy and are in constant random motion. Movement of molecules and ions that results in their kinetic energy is known as diffusion. The difference in a solute concentration creates is when it's called a concentration gradient. Solutes move more randomly in all directions, but when a concentration gradient exists, there is net movement from region of high concentrated to low concentration. Diffusion across selective permeability membrane establishes an equilibrium. Water undergoes a net movement from the region of low concentration of a solute to the region of high concentration. So it's going to be a little people, and then I want to go to that. And where the little people live is the water's going to go down. Or where the little people, where it's a lot, where there's less number of people and they go to the big group, the water goes down where the people left and gets more where the people are now. A hypotonic solution, water flows out of the vessel and its strength, and that's hypotonic. Hypertonic, everything flows in the solution inside the lipid bilayer, and it causes it to swell or burst. And isotonic, everything is equal and everything's at equilibrium, so nothing changes.